A very good morning to all dear students. In this today class, we are going to discuss about the electromagnetic waves in skin depth. How the electronic waves are going to travel in the skin depth and what is actually the skin depth attenuation is there and what is the difference between what exactly does mean the skin depth and attenuation. Two difference we should try to understand. Then we will try to explain the expression. First, I will explain the what actually does electromagnetic waves in the skin depth and attenuation. Then we will try to explain the about the expression. Electromagnetic waves. Electromagnetic waves. Waves. Its skin depth. Skin depth and attenuation. Attenuations. Understood. Electromagnetic waves in skin depth and attenuation. How it is going to happen depending on the what type of changes are there. So before discussing this, we should try to know here the fundamental thing is what we should know the background. So in the last class we have discussed about the how we can able to discuss about the electric, how the electromagnetic waves are going to travel when it is going to travel in the free space. We know very well on the free space we are having different type of layers. Depending on that we are getting different layers. Some we are having the we are having the central system, and around that we are having the surface area. And of closed surface. We know where the closed surface PDS is equal to Q naught by epsilon or Q by epsilon PDS. So this involves the closed surface. And if you take in the electric field of closed surface, we are getting another. We are getting the answer. But like that, we are having the different type of forms and equations we are going to get for the one form. So epsilon is the permittivity, Q is the charge. So this is a very important concept which would understand this concept of closed surface. Like this in skin depth, also what happens the waves, how much area it is going to have. How much area we can go into. If we are in the surface, different surface we are having, and we are having the ionosphere we are having. If the waves of attenuation is going to go inside and making some vibrations and getting returned back. Getting returned back. Why it is getting returned back? Due to the radio waves. Whatever is happening, the radio waves have the specialty to interact and come back return. Or the electromagnetic waves. The specialty of electromagnetic waves is try to interact with the largest or uppermost surface of that. If you try to take another stratosphere, it cannot able to travel. And not if travel also, it is not able to come back. Like where infrared radiation. What will happen to infrared radiation? It is going to absorb and re-emit. But the specialty does not happen through the radio waves. Understand? Of electromagnetic. We are not discussing about the IR radiation. Only we are discussing about the electromagnetic radiations or electromagnetic wave, not radiation wave. So like this, we are having the electromagnetic waves is going to travel in the form of all 3 into 10 power 8 meter. So here the skin depth. What does it mean skin depth? Skin depth is nothing but how much we are trying to send the wave. We are in the different layers. Understood? We are sin I and sin R for refractive index. V is equal to what? V is equal to sin I by sin R. Understood? So we are having the two forms. That is nothing but V equal to sin I by sin R. We are having. The waves are going to travel from one form to another. It is going to go through the two surfaces. In the electromagnetic wire, if we try to say, suppose we are having the wire. The wave is going this total internal reflection is going to happen. If it is going from one direction to another, it is starting point and ending point should be remain same. That is called the total internal reflection. If you have the wave is going in this direction or in this direction, what happens generally? The wave is going to decrease after traveling, but due to this surface area, whatever the above and below, it does not going to affect the electromagnetic wave. It is not going to affect the EM wave. It will remain. So the skin depth will explain about what the skin depth will explain. Skin. Skin is nothing but the layer. Skin is in bracket we can write as a layer. Understood? The layer will explain how much in depth it is going to go. Skin is nothing but the layer of outside. Outside. And the depth, what is the skin depth? It is going inside. Going to interact with the inside. Inside. It is what area, this area is nothing but a bounded, not unbounded. Bounded. Bounded area. Unbounded is what now? Unbounded is the no area at all. No area. It is without free. And here free means no interaction. We are only discussing about the bounded electromagnetic waves in the bounded media only. We are going to discuss in this chapter. So this entirely the wave is traveling from one direction to the other direction in such a way that we can able to get the skin and depth. Skin is the area of the upper layer and depth how much able to the wave is going to propagate. The propagation is depending on what the propagation is entirely depending on the frequency, wavelength, intensity of the electromagnetic radiations. This is a very important thing you should try to understand how. So let us describe so skin depth is nothing but a wave which is going to travel inside the medium. Understood? The medium may be thick layer or thin layer, whatever it may be. If the thin layer is there, what will happen? It cannot penetrate. If it is a thick layer, it's not better. Thin layer is what you can able to penetrate. Because the thickness is very less, then mu I is very high. Then critical angle is a very important. I will try to explain this also. You try to please write on this point, then I will explain detail. The skin depth. I will write a definition for skin depth. The skin depth is defined as the amount of EM waves travel from rarer medium to denser medium. Understood? So easily we can understand the skin depth is defined as the amount of electromagnetic waves traveling from the rarer medium to the denser medium. So rarer medium and denser we just now discussed like that we are having the critical angle mu should be greater than 1. Understood? If mu is very less, mu should be greater than 1 means it can able to understood? If mu is greater than 1, the EM waves can travel will in denser. If suppose mu is less than 1, the EM waves can travel only, please note down, we are writing only in rarer medium, rarer dense. So this is the important. If mu is equal to 0, what happens? No amount of EM waves, no amount of universe can travel in both medium. Which are another medium or dense medium. It is remain only permitted to the this layer only. Even not going inside little bit amount. That is not mu. That is not. So in order to satisfy definitely the critical angle mu should be greater than. So why the mu should be greater? So when the mu should be greater, then only the wave can penetrate. Penetrate, then only it is going to give the depth. Is going to happen. If mu is equal to 0, what happens? It is going in the reflection. Mu is equal to 0. If it is going inside this water, when mu is equal to less than 1. And it is going inside more and coming back, mu is greater than 1. Please note down, we are having the 1, 2, and 3. Understand? Mu equal to 0 means what happens? The wave is coming and returning bounce back. Bounce back. And here what happening? The wave is coming and mu greater than, only it is permitted to the R. I am writing the R. And here what happened? We are permitted to not only that is nothing but I equal to sin I by sin R. Sin I. We can write I also on R. Taylor medium. So now let us not confuse. We can write in the format general Snell's law. But here what you should try to understand means it can travel only in the Taylor medium. It can travel denser. Like that. Denser medium is down. It is permitted to what here? It is going reflecting back. Taylor medium. And denser medium is that. So like that, depending on that, we are having the critical angle. The critical angle is very, very important. The critical angle is depending on what the three conditions that are. It is dependent on the dielectric constant. Dielectric constant. T equal to epsilon of E. Epsilon is the permittivity of the material. That is nothing but D is equal to 8.85 into 10 power minus 27 into E. How much energy we of the electron? Suppose radio phase. Radio is how much we are having the 10 power 7. So what will happen? D is equal to 8.85 into 10 power minus 27. So if you minus this, what will happen? 10 power 7. If you both, last the conclusion is 8.85 into 10 power minus 27. If you minus both, what will happen? We are going to get the ending speed. So what is the integration 20? So this is the dielectric. So if the dielectric constant of the material is equal to 8.85 to 10 power 20, then only the skin depth is going to happen in any medium of the electromagnetic radiation. If the dielectric constant is not permitted to this value, then what will happen? We are not going to get the actual skin depth effect. The skin depth is very much useful in the nowadays in the application part. Suppose we are in the aircrafts. Aircraft what happens? We are going to give the signal of electromagnetic radiation. That is nothing but the radio waves. Why we are using the radio waves? We are trying to note down. Please note on these sections. We are trying to know how we are going to apply skin depth and applications also, and like this. And now I am going to explain attenuation. Skin depth is over. Now we should discuss about the what actually the attenuation is. So now let us discuss about what actually the attenuation means. Attenuation is very very important. Attenuation of electromagnetic waves. Attenuation of electromagnetic waves we are going to generate. How we are going to get this attenuation? Attenuation. What is the difference between scatter and attenuation? Attenuation is related to the definition. Attenuation is defined as the ratio of wavelength before and after penetrating is called attenuation. That's right. That is defined as what is a ratio of the wavelength before and after penetration. Before and after penetration. So simply we can call, suppose we are taking same diagram, we are taking whatever the wavelength we are having the amplitude, this will also remain same. There will be no change of the wavelength. It will remain same. Whatever the output and input. Both if you are having the wavelength is like this and output also same. If it is satisfied, if the dialectrical medium U equal to delta E equal to E naught and where E equal to naught E equal to E naught sin omega t. Under equation number 1, equation number 4. But substituting 2 in 1. Also, E equal to epsilon naught E naught sin omega. So the dielectric constant what happens? The wave can travel. The wave can travel from one medium to the other medium. So under the dielectrical medium, the wave having the propagation is same and before it is. So simply the attenuation is related to the wave. Understood? If the wavelength is very strong, what happens whenever the light is going to travel inside the medium, it is not going to affect by any external effect. Suppose we are having the different effects of the wires. Understood? Cylindrical wire, you are having the Cartesian coordinates, you are having the spherical coordinates, different type of waves are. So when the waves are going inside the structural, what happens? We are going to bounce back. Some form of the waves are going returning back outside. And what happens? Whatever the information, whatever the info I'm sending, it should remain same. Same info should be there. Okay. Info here and info here should be same. If the information is not same at the both sides, what will happen? Then it is not going to get the actual information of what we. So the attenuation can be defined as another ratio of the wavelength. Ratio of the wavelength before and after penetration. Before and after penetration is called attenuation. Is same. Please remember I missed the term is same. Is same. Is defined as the ratio of the wavelength before and after penetration is the same. Understood? Then what will happen? Then we can able to get the exact electromagnetic radiation without any disturbances. So this is about the actual part of the attenuation. And the important aspect is here, if you satisfy the attenuation principle, then we can able to get the propagation of the different forms of the waves. So now what exactly is the difference between the skin depth and attenuation is that whenever the skin depth molecule is there, means the skin depth condition is fulfilled, generally we can able to get the action. In the wave, all propagating here, then how we can calculate the ratio between the two waves. Before and then we cannot able to judge how the dielectric medium is going to change. So you please note down these key points. We'll try to discuss the difference between the skin depth and attenuation. definition and applications of the skin depth and attenuation principle. Here we will try to discuss the difference between the attenuation and skin depth and application. Difference of skin depth attenuation. Only two or three, four differences are there. Here we can write skin depth and we can add attenuation. So here what happened, the skin depth and attenuation. The difference we will try to note down. The skin depth will explain about what the skin depth related to the ratio of rarer and denser. And here also ratio of rarer and denser in terms of wavelength, in terms of lambda. Wonderful. First is. And second difference what happened in the formula D equal to epsilon naught into E plus only E. And here what happened in the second formula D equal to epsilon naught E equal to E naught sin omega because it is related to the lambda wavelength. So here what happened, the critical angle dependent. So here we are having the another transmission. We are having the transmission angle. Okay, dependent of wavelength. Lambda. Transmission is what? Lambda dependent. Critical angle. If critical angle is not saturated, we are not able to get the understood. So here what happened, the transmission angle dependent lambda we are having. And the fourth difference, last but not least. So it is skin depth is independent of EM waves. Means whatever the EM waves or whatever the skin depth is, depend on its thick or thinness of the area of the wire. And with the attenuation, it is independent of the sorry, it is depend on the EM. So whatever we are having, like this, we should try to understand the difference of the both the electromagnetic waves. Ratio of rarer and denser medium, a ratio of rarer and denser medium in terms of lambda, we should try to understand. A equal to epsilon naught E. Understood? Understood. And D equal to epsilon is nothing but related to the wave. And here what happened, critical angle dependent. Whatever we are having the critical angle dependent. Another is called transmission angle. Understood? Transmission angle is related to what and how the wave is going to propagate. But it will not discuss thick and thin areas. And here the last but not least, fourth is skin depth is independent of the EM. It is entirely independent of the EM waves. Does not whatever it only depend on the area, volume, whatever. That is nothing but integral E closed surface of boundary for dielectric material. Understand? Often it is a dependent on the EM wave. The most important point we should try to understand. So overall, in this class, we have discussed about what is meant by skin depth. Hmm? And along with the skin depth, we have also discussed attenuation, basically between skin depth and attenuation. Please note down, we'll try to discuss the application and we'll conclude this class. Hope you have noted down this. Our last point is nothing but the application. What is the application? It's used in aircraft navigation. Ah, perfect. So how it is going to use aircraft and navigation means if any type of aircrafts or pilots are going to travel from one airport to another airport, they try to use the radio waves. Understood? If the skin depth of radio is very good, then where attenuation is possible. If attenuation is not possible, suppose we are using the infrared radiations or gamma microscope, what happens, whatever the signal I am sending, it is does not going to go to the nearest station and not reflect back to the transmitter. Due to that, what happens, I am not able to get the communication. So basic use of this skin depth and attenuation is the communications. Of aircrafts, navigations are the main two sources. Why we are using the aircraft and navigation is we don't have any direction. Suppose if you want to travel from one place to another, airport we don't have like a roads where to go left, right, we can identify. But if you are traveling on air, everything is there, nothing, all remains same. If you are traveling air, this flight what will happen now, we cannot able to see left and right. All remains same. You does not able to detect which is left, which is right. Understood? There is no direction. No direction. Then here we are having the problem. So now to overcome all this, the radio waves which are going to interact or electromagnetic waves which are going to interact with the upper surface of the ionosphere and coming back and entire Earth surface. Very interesting one. This is very interesting. Again, I'm trying. It is going to communicate wherever we are having, it can easily communicate. The basic principle, because whatever we are having, its skin depth is going to happen. Skin depth is completed, what happens now? It is going to tell what is the information. If anything object is coming, if anything obstacle is coming, and aircraft is coming from here. Hmm? Aircraft is coming. So what will happen? Hmm? Aircraft is coming and what will happen? We can able to detect because it is going to transfer. You can take a different direction. You can easily go and return back. What about other waves? It does not going to return back. You cannot able to get. Suppose we are doing one flight is going in this direction, another flight is coming in this direction. What will happen? We can able to take the direction traffic. We can call that to maintain the traffic in the navigation. Aeronautics is a very fundamental usage is nothing but the electromagnetic wave. Right? Without this, no technology can develop, no technology can enhance eye without using the electromagnetic radiations or electromagnetic waves. Particularly, we can call it that. So in today's class, we have discussed about one more. What are skin depth, what is means attenuation, and before these two topics, we have discussed background, what we discussed in earlier class, and applications. And before applications also we have discussed about the difference between skin depth and attenuation. Like that, last applications, how we are using. So nowadays, there are so many number of applications are they are using about the electromagnetic waves, particularly in the fields of science and technology. So this is the particularity of the electromagnetic radiation skin depth. So you please go through this. This is a very, very important answer for extra time. When the offline classes will start on Monday, I will give you notes also. You can follow these instructions properly. So thank you for today's class. This much we have discussed.